So, hello everybody. My name is Charles Kergariou. I'm supervised by Professor Fabrizio Scarpa, and I'll be talking today about the measure of porosity in flax fiber reinforced polylactic acid biocomposites. So when I started working on this material, I wonder how could I assess the quality of my composites. In order to do this, I look at the literature at all the different techniques that are available in order to measure the porosity of these composites. You can see them in the red box. There are many of them. And so I wonder which one would be the best for my specific materials. To understand this, I needed to know what I was going to measure. So basically, it's a schematic of a natural fiber composites. So you can find the conventional pores that you find in every composite, including polymeric ones, such as the matrix pores and the fiber matrix interface voids. But you have additional voids in natural fiber composites. The voids inside the fiber, for instance, the lumen, which is a big void in the middle of the fiber. So basically, from my specific application, I needed to quantify each of these type of voids. So I wonder three things. First, what technique could be used to measure these three types of voids? How could I adapt this porosity measurement technique to natural fiber composite? And to what extent could I trust these values? In order to do this, I made 6 different measurements for the same materials. 2 gravimetric measurements, which basically consist in measuring the weight of the specimen in different conditions and extracting the porosity from this. 3 different optical measurements, CT scanner, optical microscope, and SEM, and tensile test, which consists in loading the specimen in traction, then calculating the mechanical properties, and back calculating the porosity from it. First, I would like to say that tensile tests should be avoided as much as possible from what we've seen, because when we did this experiment, we made a lot of assumptions that it was difficult for us to respect in the test afterwards. So among the 5 other techniques, we adapted them to our composites. For instance, we modify the conditioning and the time of immersion in the gravimetric measurement in water in order to be able to obtain an overestimation of our porosity. For the optical measurements, so the CT scanner, the optical microscope, and the SEM, we modify the preparation techniques and the resolution in order to underestimate our porosity. And when we are going through all the different techniques, we quickly realized that it would be difficult for us to obtain a precise value of the porosity and be sure that we were measuring every single pores in it. So basically, we were able, instead of doing 2 things, defining an interval of porosity in which we were sure our porosity was located. You can see in this graph. It was defined by the gravimetric measurement in water as upper bound and the largest optical measurement as lower bound, in our case CT scanner, and we were able to obtain an estimation of the porosity thanks to gravimetric measurement in ethanol, which is fairly quick to conduct, cheap, but the main issue is that we were not exactly sure what we were measuring because we don't have a great insight in the interaction between ethanol in our material. So we backed it up with the CT scanner in order to obtain our porosity and know which kind of pore we were measuring. Basically, if you want to make measurements in natural fiber composites, you need to know if you want an overestimation, an underestimation, an approximation, which type of pores you want to measure, the size of pore you want to measure, select your technique and adapt it to your materials. If you want greater insight into this, we published a paper with Fabrizio recently, and you have a comparison between the different techniques. Thank you for listening.